So those movies you watch,
No.
that's inappropriate.
Okay.
It's a romantic comedy with some suggestions.
So it's recording already. We are going to actually put purpose into these matrix equations. Do you remember last chapter that you hated so much? We had to solve systems of equations. So like we were looking for the point where the graphs crossed. Yes, and we had 3 methods to do this. What were they?
Process of
Substitution, elimination.
Elimination, substitution.
Or you can plug negative y equals plug in the calculator and do your second.
Yes, graphing, right? And find the intersection. All right, we're going to add a 4th method today, and that is matrices. That's the whole point of this whole chapter is this. So we can solve systems using matrices. So what's going to happen is we will convert this to a matrice that looks like this. Do you see the connections? Like what number goes in front of that X right there? A 1. So where the 1, 2, 3, 5 are all right here, the X and the Y turn into this second matrix, and then the answers are the last matrix. Yes? You see the connection between those two. All right, each matrix, so each of those 3 matrices has a name, and I made a typo.
Like seriously?
All right, it's equals instead of that.
Oh, right here.
In the box, in the sentence. Oh, I made it white. I didn't erase it. I just drew over it. Okay, so each matrix in the equation form of A times X equals B has a name. So the first matrix, which is made up of all the numbers, what are those numbers? They are the... No, it starts with a C. Coefficients. It's the coefficient matrix. Good job, Wayne. Are you writing this? Yes. Oh, just with that one. That's the coefficient matrix. The next one, what are those? It's the variable matrix. Way to go. And the last one, those are our constants. So that is the constant matrix. They don't have variables attached to them, so they don't change. They are constant. All right. So our first task is to just set up a problem from the system of equations into a matrix. Now here's what we're going to go by. In order to be able to do this, all the variables have to line up. So we've got to have a column of A's, a column of B's, and a column of C's. Okay, we can't like scoot this B to the beginning. That messes it up. Okay, so you always have to have them in order, lined up. And let's fill in the holes. So this right here, if I was to put an A there, what would the number be in front of it? No, a 0. That's what makes it disappear. Okay, but what is in front of that B? A 1. Okay, in front of this A, in front of that B is a 1, C is a 1, and then what's going to go in this spot? 0B. And I'll go ahead and put a plus so we have it all there. All right, so now we have all of our numbers. So what will our first matrix look like?
-1, 2.
We got to use all the numbers. So 0, -1, 2. Okay, keep going.
1, 1, -1.
Uh-huh.
And 2, 0, 3.
2, 0, 3. All right, and what is that one called? What's the name of that matrix?
Coefficient matrix.
Yes, that's the coefficient matrix. The first problems on your homework are like this, where you make the matrix and then you label it. All right, then the next matrix, what will that have in it?
that'll just have X and Y.
From the last one, it was X and Y. But what are our variables here?
A, B, and C.
A, B, and C. And then that equal, oh, what's the name of that one? Variable matrix. Okay, and then the last one, what was it? 4, 0, 11. And what's that one called? Constant. Okay, so the first problem's on your homework. That's all you have to do, is put it into the matrices and then label them. You don't have to actually find anything. Any questions on that? If you, and it always has to be in standard form. Standard form was when all the variables were on one side and the constants are on the other. So if they give you equations that aren't set up like this, like maybe A is on this side and B and C are on that side, you're going to have to move them first. Okay, so there'll be all the letters equal numbers. All right. Now, how can we actually use this? When possible, finding the inverse of the coefficient matrix can be used to solve a system of equations quickly. Basically, we're going to use what we did yesterday to help us solve this. And y'all liked yesterday, I'm pretty sure. So first thing is to set up the matrix equation. So what will our coefficient matrix be?
2, 3, 0, 2. 1.
1, 2, yes. And then what will our variable matrix be?
X and Y.
X and Y, and that will equal 11, 6, right? All right, so now that is in the form A times X equals B. So we are going to find matrix X by using the formula we did yesterday, which was A inverse times B. Remember that? It's your best friend. So we can do that in the calculator by putting in matrix A, using our inverse button, and putting in matrix B. So do that. Enter matrix A in your calculator. It'll be a 2 by 2. Enter matrix B. What will the dimensions of that one be? 2 by 1. Okay, so go ahead, enter those in, and then we'll find A inverse times B. So you should have gotten it to look like this. Did everybody get that? So yesterday we would have written that matrix X equals 4, 1. But today it actually means something else, because our X matrix was this right here. So it equals X, Y. So what does X, the variable X, equal? What does Y equal? So write that as an ordered pair. Your answer is 4, 1. Because we're dealing with systems of equations, we have to say specifically what our numbers mean. So that's why we write it as a ordered pair. So that is where those two graphs would cross. That's pretty good, right? So now we have 4 methods to solve equations: graphing, substitution, elimination, and matrices. All right, so when you take tests and it asks you to solve them, remember all your options. Okay? Y'all ready to go to the next page? Anybody have questions? Example 3, we follow the exact same steps, but it's just bigger. So what size will our coefficient matrix be? 3 by 3, right? We've got 3 equations and 3 variables. So that coefficient matrix will be 2, 1, 3, 5, 1, negative 2. So negative 1, negative 1, wait, 1, negative 1, and 9. Okay, make sure you always include those negatives. All right, what is our variable matrix? X, Y, Z, written as a column, and then our constant matrix is what it says, 185. If, just so you know, if you did matrix multiplication and multiplied these 2 together, you would come back to something that looked like this. Okay, because it would be 2 times X, 1 times Y, and 3 times Z. All right, and then you would add them all together. So there's method to this madness. Okay, so A times X equals B. So in your calculator, put in this 3 by 3 for A, and the 3 by 1 for B, and then find A inverse times B. So if this equals our variable matrix, X, Y, Z, then our ordered triplet is 4, negative 10, 1. Did anyone have trouble finding that? Anybody have questions? Okay. Y'all like this so far? Okay then. Next question is kind of a word problem, but it's kind of already set up for you. Says a bead store, I know you all like to go buy beads, has a sale on certain beads. Find the prices of each size bead. So you can get 2 large beads and 3 small beads for $3.25. You can get 3 large beads and 4 small beads for $4.75. So we need to know how much a large bead by itself costs and how much a small bead by itself costs.
Those are expensive beads.
They are expensive beads. All right. So maybe they're like real glass beads or something. So we need to put some variables in. So we have large beads and small beads. What letters do you want to use?
L and S.
L and S. All right. I'm going to use a cursive L so it doesn't look the same as everything else. L, L, S, and S. So if we write those as equations, we get 2L plus 3S equals 325. And then 3L plus 4S equals 475. You're correct. 2, 3, 3, 4 is the coefficient matrix. What's our variable matrix? LS and 325. 475. So if you take this, plug in the first the coefficient matrix for A, the constant matrix for B, then find A inverse times B. Alright, so we plug them in. So 2 by 2.
Dude, you were in my dream last night.
It's recording, just by the way.
It was so weird. We were like sledding in Sherman on the road.
That's kind of
And
weird.
we almost got hit by a car. You know, like we were sledding, you know, you get on like a four-wheeler and you have to lean.
Yeah.
We were doing that, and like we leaned the wrong way, and a car hit us. And I was like, and I woke up and I was like, no, I didn't tell them if we died or not.
What did you get for your answer matrix?
Negative 0.25.
Negative
Yeah, I just
0.25?
used 25. I just took the negative off.
Get done, Cooper.
Okay, so you should get 2 numbers for your answer matrix.
Oh, yeah, I did. But
So you should get $1.25 and then 25.
It's like, dude, having to laugh at the Oscar decided to get run over part. Like,
So how much do the large beads cost, Kobe?
$1.25.
Okay, so large beads are $1.25. Make sure you put your dollar sign. It's a word problem. You always got to label it. Okay, how much do small beads cost?
25 cents.
25 cents. Or $0.25 dollars. And that would be your answer right there.
Yeah, did we not use cents anymore when we were little? Like, we was just cent sign?
If you want to, you can. Just make sure there's no decimal. 0.25 cents isn't very much. Quarter of a penny. All right. So, this last part, you don't actually have to like solve for anything. All we're trying to see is if the system has a unique solution, that means that it has one intersection point. It's like it makes some sort of an X, okay? So you're just trying to find if it has one of those or if it doesn't, which would mean it's either a coinciding line or parallel lines, okay? Now how you can tell is from the inverse. If matrix A has an inverse, then it does have a unique solution. Okay, so that would be lines that cross with just one intersection point. If it doesn't have an inverse, then it doesn't have a unique solution. So that would be coinciding lines or parallel lines. You don't have to tell me which. You either say unique solution or no unique solution. It says doesn't.
Oh, I didn't make these.
All right. So we have several different ways to figure this out. You can, no matter what, we have to find our coefficient matrix first. All right, and then we can either put it in the calculator, tell the calculator to find its inverse, or we can use the determinant. Because the determinant, we know that if the determinant equals 0, there was no inverse. If the determinant equals anything else, there is an inverse. So we'll do this, I don't know, whichever way y'all think is fastest. So first thing is find coefficient matrix. Having trouble writing, sorry.
1, 1, negative 1.
All right. So you say 1, 1, 1, negative 1. Very good. So we can either find A inverse in the calculator or find the determinant of A. Which the determinant of A you can do in the calculator, but what was the formula for determinant of a 2 by 2? If this is A, B, C, and D, do you remember?
A, D, B, C.
A, D minus BC. And honestly, I think just doing that is faster. Because what's A times D? -1. And then minus, what's B times C? 1. So that equals -2. If the determinant is not 0, that means it has an inverse, which we just learned means it is a unique solution. So that would be your answer. Sorry, wasn't quite enough room, at least on my page. I abbreviated solution. So our answer would be unique solution. So that means those two graphs cross in one place.
That's it?
That's it. So let's do the same thing on the next one. Like I said, I think it's faster to do it without a calculator. What's the coefficient matrix of the next one? 1, 2, 2, 4. So what will AD minus BC equal? 4 minus 4, which is 0. And that's the determinant. If the determinant equals 0, what does that mean about an inverse? No inverse, which means no unique solution. And you are good to go for your homework. Any questions? Yes?
So what order is that A, D, B, C? It's like A, B, C, D?
It's, yeah. A, B, C, D.